Global semiconductor product revenue reached over $500 billion in 2023, enabling advances in communications, computing, clean energy, transportation, and countless other applications. Semiconductors have become essential to daily life.
It's fascinating how semiconductors have changed our world. They have been a huge change to every single industry. They were introduced more than 50 years ago, and now it is inside every single product we have in our hand, everything that runs with electronics. So we know we have all our communication tools, our phone, our smartwatch, our laptop, our smart home. And there won't be any electric cars without semiconductors, and no plane will start without a semiconductor inside. So semiconductors do make our life so much easier, safer, and convenient.
Often referred to as the DNA of technology, microelectronics are used in every major industry across the world and are necessary for the production of most products, making them essential to the global economy.
Virtually every industry and product that we use on a daily basis rely on microelectronics, whether you realize it or not. And these components, we're talking about features that are not even visible to the human eye. And those small microscopic components need to be assembled and put into a final product. And that's really what the term microelectronics refers to. Some of the challenges of assembling microelectronic components really just comes down to the microelectronic size, and then the chemistries involved in connecting these small parts into an assembly can be a challenge, whether it's a solder or an adhesive.
As the universal demand for miniaturization of electronics increases, the volumes needed when scaling require faster equipment to reduce cycle times while maintaining high accuracy and process repeatability.
It is not possible to create a full functional module just out of one integrated circuit. So there's always stitching and stacking of those components to form like a chiplet or another integrated product, like a system on a chip. The equipment that's needed needs to align and bond those small components, which have millions of contacts in a wafer scale. And the precision of the machine then defines the yield. And it would be very easy to waste a lot of parts very quickly when the precision equipment fails.
Now, the growing need for submicron placement accuracy in many advanced technologies is pushing the manufacturing world to improve equipment specifications and process capabilities.
Advanced technologies today require submicron accuracy. To give you an idea of what submicron really means, a typical human hair is about 50 microns in diameter. And so now picture splitting that hair maybe into another 150 or 160 thinner pieces. That is the type of accuracy that we're talking about in today's microelectronics.
If the components are getting smaller and the alignment accuracy and placement accuracy needs to be better, then the equipment has to provide. And so for this, the equipment manufacturers have to react and also be one step ahead.
Businesses need more than just equipment to help them on their journey from concept and development to production.
Finetech make machines to assemble semiconductors and other microelectronic components, and we support customers to find the right way and the right process to build their product.
In the production of microelectronics and optoelectronics, the choice for the best possible bonding technology is one part. With the core feature of our bonders, the high precision and repeatability, which is passive optical alignment to some like 15 nanometers in accuracy, we need to combine it with the core technology for bonding. And also the throughput comes from this part. So the faster you can bond and the faster you can handle the components, the faster the whole production will be.
An extensive range of high-accuracy microassembly bonding equipment helps to support precise and complex applications at the research, prototype, or production stage.
Finetech has been supporting academia and research centers for more than 30 years. And those ideas must be done on a tabletop system like we offer, but it must be easy to use and it has to be flexible because ideas change, different processes need to be tried, but at the same time have a way of taking it out of the R&D lab and moving it into production. So our technology has really helped in some amazing areas. Our equipment is critical for helping high-power lasers be incorporated onto the Mars rover and for the James James Webb Telescope. We were working with micro shutters getting to the diameter of a human hair. Another good example is LiDAR and lasers and photonics, and that technology is becoming available everywhere. We're seeing more and more autonomous driving.
In addition, the intuitive and powerful IPM command binding software allows users to concentrate on core tasks, minimizing operator errors, while providing access to an unparalleled range of parameters.
If you have an automated machine for production, you need to tell the machine what to do, and you need to tell it precisely. So a control software needs to provide a good recipe and show all the ingredients. And it's like a big kitchen, and our software, together with the equipment, with the machine, brings this all together. So the accessibility, the way how to visualize results, is key to fine-tune the recipe. Microelectronics and the manufacturing of microelectronics will be the main driver and also the main supporter of future equipment. Of course, it always will be about material and design and physics, but I think the focus will go to the software part. So using artificial intelligence, machine learning, and ways to use traceability and feedback more information into this equipment will enable to keep the machine in the sweet spot, which is crucial for a high precision machine.